Hello everyone, today we're going to be talking about how multiplication works. Hopefully this is going to lead us into some other more complicated multiplication topics, but for now let's talk about the basics. So here I have one example of a way we can think about multiplication, where multiplication is repeated addition. This is one way to think about it. So 3 times 5, okay, if you listen to the words, 3 times 5, it means you have 5 3 times. So this is 1 time, this is 2 times, this is 3 times. Okay, it's describing what you have. So we have here 3 times 5, and that would give us the sum of these, which would be 15. Now if I change this to, like, let's say 6 times 5, then all I would need to do is have 6 5s, right? So this would be 6 times 5, 5 plus 5 plus 5 plus 5 plus 5 plus 5 gives you 30. So that's one way to think of multiplication. Now, it really doesn't matter which one is the number that you're making copies of and which number is the amount of copies. So 5 times 6 is the same thing as 6 times 5. So if I wrote this, or if I wrote this, that's the same thing. And they can both be represented by either this picture or this picture. Now, another thing you can do is instead of making groups in order to multiply, if you can see groups, that can be interpreted as a multiplication. So if someone were to ask you, hey, how many squares are there in this picture right here? Now you could just count them and you'd get 30, but multiplication can make it much easier, because what we can see is we can count one row and we can see that's 1, 2, 3, 4, 5, 6, and then we say, okay, well there's 6 in each row because they're all the same size. How many rows are there? There's 1, 2, 3, 4, 5. So there's 5 rows and there's 6 in each row. So we can think of this as multiplication. 5 times 6. How many is in here? There's 30. Okay, over here, same thing. So we can count how many is in each row, or how many is in each column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10. And then we've got 4 columns of 10. So this would be 10, 10, 10, 10, which is 40. Right? So 4 times 10, that's 40. 5 times 6 is 30. So these are a couple of visual representations that we use to help us understand what multiplication can look like. And it's using these we can then begin to understand some of our standard algorithms. So let's say that I asked you how many squares are in this big rectangle here. How many are there? So we can multiply. We use the same thing, so we just count. This row has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me just count that again. 4, 8, 12, yeah, 15. And then this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 times 15. Now, you might say, well, I don't know what 12 times 15 is. But that's okay, because we can use this visual to understand, and all we have to do is just kind of separate these into ones that are a little bit easier. So we really like counting by tens and by ones, so let's break it up into that. So what we can do is we can answer that question by breaking it up into amounts that we know are easy to calculate. So for instance, what I did was I said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're going to stop there, and all the rest are going to go over here. So remember, this was a row of 15. Now we've got 10 and then a row of 5. So by breaking it up into these smaller sections, we'll be able to do this multiplication much faster. Remember, we were doing 12 times 15. So what we can say is we've got 10. And then we say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this section is 10 times 10. That's 100. Okay, now this section we've got 5, and if you notice, these are the same size going this way, so we've got 5, and then there's 10 in each one, so this is 10, 20, 30, 40, 50. There's 50 in this one, so this is 100, this one's 50, this one's 10, 20, so there's 20 in here, and then this one's 1, 2, 3, 4, 5 times 2 rows is 10. So you've got 100 plus another 50 plus another 20 plus another 10, right? So that's 100 plus 50 plus 20 plus 10, right? And we can add these up, 150, 170, 180, right? So we get 180. Now, this picture represents our standard algorithm, which I'll show you in a second. This is what we usually use when we multiply. It looks like this, right? So we organize them 12 times 15, and then the standard algorithm is to say 5 times 2 is 10, so we put the 0, carry the 1, and so on and so forth, right? And so that gives you 60. 1 times 2 is 2, and we put a 2 there with a 0 there as a placeholder. 1 times 1 is 1. Put that here, and then you add, and you get 180, right? Which is this. That's this 180 that we got, right? 12 times 15 is 180. Now this shortcut here is actually a very shortcut way of doing this, which again is just another representation of this. Okay, now what happens is a lot of times teachers will show this and they'll ask you to memorize it, but if you don't know what this means, then it really messes you up in algebra, because you're trying to do algebra by memorizing instead of by actually understanding what's going on. So it's fine to do it this way as long as you understand what's going on. And so over here I have a little bit more of an expanded form, and you can see exactly what's going on. So again, we had 12 times 15, and remember when we broke it up over here, we had a section that was 10 times 10, we had a section that was 5 times 10, we had a section that was 2 times 10, and we had a section that was 2 times 5. Okay, we had 4 different sections. So when we go through and we multiply here, if we multiply 5 times 2 and we get 10, that gives us this section. So we're going to do 5 times 2, 5 times 1, which is 50. That's supposed to be a 50. My mistake here. That's a 5. 5 times 1 is 50. Okay, 5 times 10 is 50, and that gives us this section. And then 1 times 2, which is 10 times 2, that's 20, which is here. And then the 1 times 1 is 100. So every single one of these little multiplications, there's 4 of them, right? Even when you're doing it over here, it's 5 times 2, 5 times 1, 1 times 2, 1 times 1. Okay, these multiplications, there's 4 of them, each represent one of these sections, right? So this 5 times 2, that's this section. 5 times 1 is actually 5 times 10, because that's a 10 in the tens place. So 5 times 10 represents this section. 1 times 2, that's 10 times 2, represents this section, and then 10 times 10 represents that section. So what we're actually multiplying, when we multiply this way, or even this way, or this way, this is all representing this type of thinking. So again, it's fine to do it this way, but it's very important that you understand when we're multiplying, this is what multiplication is, and this is how it works. I hope that helps you understand how multiplication works. That, to my knowledge, that explanation of multiplication and that understanding of that concept, if you can understand that multiplication is you're looking for repeated patterns, and you're adding up those patterns. If you can understand that and you can visualize that, it makes algebra so much easier. Check out my other video on more advanced multiplication with variables to show you, to see what I mean. Anyway, have a great day, and I'll see you later.